Hey everyone, and welcome to The Explainer. Today, we're setting the stage to master the absolute foundational concepts of modern cloud architecture. If you're looking to build a rock-solid understanding of the cloud from the ground up, and especially if you're tackling those vital core concepts from Module 1 that pop up constantly in exams, well, you are in exactly the right place. So let's dive right into the architect's blueprint.
Here is our roadmap to mastery today. We're going to start with the cloud computing core, decode the NIST reference model, break down cloud service models, explore cloud deployment models, and finally, weigh the benefits and challenges.
Section 1. The Cloud Computing Core, Moving Beyond the Local Server.
It's a term we literally hear every single day, right? But what exactly is the cloud? Let's shift our mindset away from the abstract buzzwords for a second and get down to concrete definitions. At its absolute core, cloud computing is simply the delivery of computing services. We're talking servers, storage, databases, networking, software, analytics, the whole shebang, all delivered straight over the internet. Instead of owning the heavy hardware yourself, you're tapping into this massive, super flexible resource pool.
Think about traditional computing. Honestly, it kind of traps you. It limits you to physical hard drives, relies entirely on local servers, and creates these massive administrative headaches and sky-high maintenance costs. Cloud computing completely shatters those boundaries. It delivers your data and programs on demand through fast, reliable internet connections on third-party hosted servers. Instead of buying software individually for every single user in your office and manually updating it, the software is just offered as an on-demand service. It's fast, it's incredibly flexible, and it scales exactly as your business needs change.
Section 2. The NIST reference model, the ultimate standard.
Okay, if you're preparing for any rigorous evaluation of cloud architecture, the NIST reference architecture is absolutely crucial. It's the gold standard. It elegantly organizes what is honestly a massive ecosystem, cleanly separating the environment into two distinct categories: the operational deployment and the nature of the service itself. Notice how the cloud provider orchestrates everything right in the center, starting from the physical hardware and facilities way down at the bottom layer, moving up through the resource abstraction, all the way to the actual service layer at the top. Now, to really digest that complex ecosystem, we've got to break it down into the 5 major actors defined by NIST. First up is the cloud consumer. That's the principal stakeholder who actually uses and pays for the services. Then we have the cloud provider, the organization actually making all that computing infrastructure available. Third is the cloud auditor. They're an independent third party that conducts assessments of security, privacy, and performance to make sure all the rules and policies are actually being met. Fourth, we've got the cloud broker, an entity that negotiates relationships and manages the delivery of services, basically so the consumer doesn't have to deal with the complex stuff. And finally, the cloud carrier. This is the telecommunications provider that actually supplies the wire-level network connectivity. Knowing exactly who does what is literally the key to mastering this entire model.
Section 3. Cloud Service Models, Packaging the Architecture.
Before we look at the specific models, we really need to understand the philosophy behind all of them, and that's utility computing. Think about how you use electricity. You don't build a power plant in your backyard, right? You just flip a switch and pay for exactly what you use. Well, the cloud packages computing in that exact same way. It's a metered, on-demand model. Just remember to turn off your virtual supercomputer when you're done, or you're going to get a utility bill that is truly terrifying. So building on that utility concept, the cloud delivers services in 3 primary steps, or models. Let's walk through this progression. Step 1 is software as a service, or SaaS. Here, you just access the front-end user interface. Think of web-based email. You just log in and use it. Step 2 is platform as a service, or Paas. This gives you a ready-to-use environment where developers can deploy custom apps without stressing over setting up the underlying hardware. And step 3 is infrastructure as a service, or IaaS. This hands you self-contained, bare IT resources like virtual servers and storage. The absolutely crucial takeaway here is recognizing how the burden of control and maintenance heavily shifts from the provider over to you, the consumer, as you move down from SaaS to IaaS. When you're evaluating these delivery models, the key differentiator, and a highly tested concept by the way, is that shifting level of control. With SaaS, your control is strictly limited to basic usage configuration. Moving over to Paas, you gain moderate administrative control so you can manage the applications you deploy. But with IaaS, you are granted full administrative access to the virtualized infrastructure. It's a direct trade-off, really. IaaS requires you to actively configure and manage the bare infrastructure and operating systems yourself, while SaaS requires almost zero administrative effort from your end.
Section 4. Cloud Deployment Models, Placing the Infrastructure.
So where does all this actually live? We have 4 primary deployment environments. First is the public cloud. It's available to the general public, it's highly economical, and it's owned by a vendor like Amazon or Google. Second is the private cloud, which is restricted to a single organization for internal use, offering some really tight security boundaries. Third is the community cloud. This one is shared by organizations with common concerns. Picture different national government agencies sharing a secure infrastructure. And finally, the hybrid cloud. This blends the models together, allowing a business to keep its most critical data locked down on a private cloud while leveraging the public cloud for scalable shared applications. I'll supply a real-world scenario to really cement the difference between public and private deployments. Imagine you're launching a highly sensitive defense application. Now, the public cloud promotes multi-tenancy, which basically means unrelated consumers are sharing the exact same physical resources. While that's highly economical, it creates inherent security and privacy risks. So for your critical defense system, no way. The private cloud is your only choice. Despite the significantly higher costs and management overhead, it gives you the absolute internal control and the isolated security boundary your application demands.
Section 5. Benefits and Challenges, an Objective Evaluation.
Let's do a rapid fire of the massive advantages that are currently driving global cloud adoption. First up, the huge reduction in total cost of ownership and CapEx. You don't have to buy massive, expensive servers upfront anymore. Second, quick deployment. Your developers can spin up brand new environments in seconds, totally bypassing slow, clunky procurement processes. Third, you get essentially unlimited storage capacity with really robust data loss prevention. But honestly, the absolute greatest tool for a growing business is the incredible scalability. If your bandwidth demands suddenly spike out of nowhere, you can dynamically increase your capacity without ever touching a single piece of physical infrastructure. It's a real game changer.
However, we've got to contrast those amazing benefits with the harsh realities of the system, because no architecture is perfect. Trusting a third-party provider with your critical lifeblood data, that is a massive leap of faith. Plus, ensuring fault tolerance and high availability in a system you don't physically control means you need some incredibly strict service-level agreements. Another huge headache is data lock-in. Because cloud platforms often lack standardized methods for storing your data and apps, trying to move your operations away from a provider that isn't pulling their weight can be incredibly difficult. And finally, there's the incredibly complex challenge of resource sharing, figuring out how to efficiently slice up and secure physical CPU and network bandwidth among potentially thousands of different tenants. Which brings us to a final, absolutely critical consideration. The architectural blueprint we've reviewed today offers some undeniable power, but unlimited scalability and dynamic resource pooling come with a price, and that price is the surrender of total physical control. So as you step into this world of multi-tenant environments and shared responsibility models, you have to ask yourself, are you fully prepared to secure the cloud? I really hope this explainer has given you a clear, structured lens for understanding modern cloud architecture. Keep reviewing these frameworks, and as always, stay curious.